All right, so we are going to be doing a lesson today about how we can use graphic organizers. So the first thing I want to talk to you about is what a graphic organizer is. So we're going to split it into its two parts. So the first part is graphic. By raising their hand, who can tell me what's a graphic? What does graphic mean, or where have you heard it from before? Miss Nina?
A visual.
A visual, good. Anything else, Montreal?
Graph.
An actual graph, like what? What do you think of when you hear the word graph?
A chart.
A chart, okay. Ayush?
A picture.
Pictures, Ritako?
Like where you display data?
Where you display data, Joey?
Where you it's like you can see it
So things that you can visually see with your eyeballs. Perfect. Last one.
It's where you could see what you were talking about and everything that's shown.
Okay, beautiful. So we know that it's something that's going to be visual. We know it's something that might be a picture. Great. All right, this word, some of us struggle with a little bit, but I bet you we know what it is. What is an organizer? What does it mean to be organized? Angela?
To have all your stuff in a certain place in a certain order.
Okay, certain place, certain order. What else? Montreal?
Neat.
All right, neat, good. Nina?
Prepared.
All right, prepared. Troy?
You gotta chunk things out into paragraphs.
Okay, so chunking things out.
Yeah.
Okay, and Alex?
You know where everything is.
Knowing where things are. Good. All right, so what we are going to do is we are going to learn about how you can use a graphic organizer to better help you understand what you are reading, okay? Montreal, do you need to go get a drink?
Yes.
Okay, take the boys' pass and go, please. Boys' pass, boys' pass. Thank you. All right, so, refocus. Okay, graphic organizer to help us better understand what we are reading. So, we are going to be reading about a sciencey topic today. Yes, darling?
What does that second one say?
Picture. Picture. All right, so we are going to be learning about a sciencey topic today, and we're going to be making a graphic organizer with a certain purpose. It's actually a purpose that you are super familiar with because it is the purpose behind the paper that you are writing in literacy right now. So, by raising their hand, who can tell me what your paper is about in literacy right now? You are writing some wonderful, wonderful papers. Nolan?
Compare and contrast.
Compare and contrast. Beautiful. So, by raising their hand, who can tell me what it means to compare and contrast? What does it mean to compare and contrast? Yomna?
Define similarities and differences.
Similarities and differences. Perfect. We have also done this in science recently. Can anybody think of when we did compare and contrast recently in science? Nicole W.
For the mac and cheese and photosynthesis.
When we compared making macaroni and cheese to the process of photosynthesis. Perfect. So, we are going to be comparing and contrasting today 3 different items from outer space. Okay? So, when you're making a graphic organizer, there's a lot of different options. You can make things like a Venn diagram. You can make a chart, like you guys mentioned. You can make a table. You can make a T-chart. Today, because we're comparing 3 outer space objects, we are going to try and make a chart, okay? If charts aren't your style and you'd rather do a Venn diagram, that's okay, all right? But up on the board, I'm going to be showing you kind of what a chart looks like. Yes, Joe?
I forgot what all those things look like, except for the cheat chart.
Okay. What did I just say I was going to do up here?
Oh, never mind.
Okay, beautiful. Thank you. So, in our chart, we are going to be comparing 3 things. So, here's what I'd like you to do. We're going to make a table on the piece of paper that I gave you. It's going to need 4 columns.
Up and down.
All right, Angela, sorry.
Does it matter if it's a vertical or horizontal?
It does not matter if it's vertical or horizontal. Good question. Montreal.
I'm going to write it now.
Yeah, we're going to write this chart down on that piece of paper I gave you, please. And And this is up to you guys. You can make, the great thing about using your graphic organizer as a tool is you can make it work for you, all right? So make it in however way or whichever way you would like to, all right? As long as you get the main things across. So the things that we are going to be learning about today, I said they were outer space objects, are comets, asteroids, and meteors. Alrighty, I'll give you a minute, 2 minutes to get the basics of our chart drawn, and then we'll talk about where we're going to go from there. Yes, Ayush.
Is it okay if I leave this about the band?
Yeah, that's fine. That'll still work. Thank you. It says asteroids.
Miss Holland, Phil.
Coralie, what do you mean?
Miss Holland.
Okay, that's fine. Thank you. What's up?
It fell.
Okay, that's all right. We'll put it back up. Thank you for fixing it.
It looks good though.
Perfect. Thank you. Leave it alone. Leave it alone. Thank you. Is it still recording?
It looks like it.
Okay, beautiful. All right.
Yeah.
Then, how are our charts? Ready to go?
Yeah.
Mm-hmm.
All right. Beautiful. So, we're comparing comets, asteroids, meteors. So, I know you guys talked about this when you did your compare and contrast papers in literacy. What are things that you could compare and contrast, do you think? What are some things that we could compare and contrast? You could think of a general word. You could think of specifics. What are some things we might compare and contrast? Troy?
Can we do like a triple Venn diagram on this?
You could. A triple Venn diagram would work, and that is a complete option. I'm going to do a chart up here on the board. If you would rather do a Venn diagram on your paper, I'm okay with that. Venn diagrams for me personally, my writing's really big and it gets kind of goopy and confusing. I'm more of a linear, logical person, and I like the chart. So it's up to you, but yes, that would work, okay? So, what kinds of things could we be comparing and contrasting? Gracie?
Well, we can compare that they're involved in space.
Okay, so, perhaps their location?
Yeah.
Okay, Montreal?
Wait, does it have to be between those three?
No, it could just be something in general.
Stories.
Okay, stories. You could compare and contrast stories. Angela?
People.
All right, people. Ayush?
Space.
What about
Space
space?
Objects.
Objects, and that's what we're doing today. Joey?
You can do like just things in general. You can do basically anything.
Okay, so here, let me try and make this a little bit more specific for you. Hang on one second, and I see you're very excited. When you wrote your compare and contrast papers for your literacy teachers, what were some of the main points that you were comparing and contrasting between your two characters? What were some main points that you were comparing and contrasting between your two characters? Montreal?
Like setting.
Okay, setting is one. That's possible. Nicole W?
Like characters.
Characters and characteristics. That's the word I was looking for, so thank you. Angela?
I was gonna say plot.
Plot, that would work. Nina?
The effect they have on the story.
The effect they had on the story. Good. For our purpose today, and in science a lot, because in science, obviously not the same as literacy, there's not always a setting or a plot or characters, but there are characteristics, because these are objects. And can objects have characteristics? All right, beautiful. So, this last column is going to say the word characteristics, and I am going to have to squeeze it over into the other column. Yeah, go ahead. Thank you for asking. All right, can anybody, before we start, because we're going to think of more while we're reading, can anybody, before we start, think of what might be a possible characteristic for something out in space? What would maybe be a characteristic that we could compare between three outer space objects? Nina?
How big they are.
Okay, possibly size. That's a good idea. We can jot that down. Montreal?
Shape.
Shape. That's a definite possibility. Thank you. One more idea. Angela.
How fast they travel.
Okay, speed, travel speed. There we go. Okay, so here's what we're going to do. I only have 3 up here right now, and there's a reason for that. Because, what do you need? Yeah, go ahead and grab it. Thank you. All right. The reason I only put 3 up here is because while we are reading, it's okay, just pick it up. While we are reading, I want you to be brainstorming and writing down other characteristics that you think we might be able to add into our chart. And feel free to add them in while we are reading. Okay? So, after you've got a couple things written down for characteristics, if you had more that you had inside your noggin, go ahead and jot them down. And after you've done that, we need to open your textbooks to page 730, please. 730.
Miss Connolly,
Yes, dear.
what a characteristic as such as what type it is would be something?
What type it would be?
Yeah, what type it would where it would be. Where you would see it.
Oh, like location?
Yeah.
Yeah, you could do location. That would work.
730.
730, correct.
What color?
You can do some colors. All right, I need everybody to have a textbook open to page 730, please. 730. Yes, Montreal.
Do we have to make those lines that go down between?
The horizontal lines?
Yeah.
If it lines up with the lines of your paper, that's fine. These graphic organizers, I'd like you to use them in whatever way works best for you. That's the idea, okay? Is that you should be able to create your own graphic organizer when you need to. All right, so make it work for you. So, yes, Nina.
When we fill out our American dress,
Uh-huh.
can we put like the location, or does it just have to be about the comets, the asteroids, and the meteors itself?
It would have to be the location for each individual object. That's how the chart would work. So, for example, we're going to read about comets first. So while we're reading, or briefly after we're done reading, you're going to fill in items right here in the comets column. All right, for whatever you guys come up with. It might not be identical to the person next to you, and that's okay. Yes, Ange?
For the last box, anything that you want.
Any characteristics that you realize might be a good idea as we're reading, add them in there.
Okay.
Definitely. Yes, Joe?
What about order here?
Yes.
Yeah.
Yes.
This is like a comparing thing, but like.
Yeah, what's up?
Can you compare like the solar system with the planets?
That would be another excellent opportunity to use a graphic organizer to compare the different planets. And it would look very similar to this. And actually, in about 30 days, we will be doing just that. So, you guys are ahead of the game. Yes, Nina?
I sharpened my pencil.
Of course, you may sharpen your pencil. All right, so we're going to read comets first. I'm going to be the one that reads first, and then next couple chunks, I'll ask for volunteers, okay? So, comets. It says, one of the most glorious things you can see in the night sky is a comet. But what exactly is a comet? You can think of a comet as a dirty snowball. That's one of my favorite nicknames ever in science. About the size of a mountain. Comets are loose collections of ice, dust, and small rocky particles whose orbits are usually very long, narrow ellipses. That word ellipse is a little bit of a new word. Does anybody know what an ellipse is? Or have any context, like where you've heard the word ellipse or elliptical? Ayush?
It would be something. Something big.
Not necessarily big. It's a type of shape. Any ideas? Troy, do you know what an ellipse is?
I'm looking in the glossary.
Yeah, what'd you find in the glossary?
L-I-P-S-E.
That is correct.
An oval shape which may be in longitude or nearly circular.
All right. An ellipse is a circular shape that can be really pulled out like this or look almost pretty circular. All right. So, no, you don't have to write that if you don't want to. I just wanted to make sure we all understood what an ellipse was. All right. Continuing on. It's broken down into the 3 parts of a comet. A comet's head. When a comet gets close enough to the sun, the energy in the sunlight turns the ice into gas, releasing gas and dust. Clouds of gas and dust form a fuzzy outer layer called a coma. Figure 24 shows the coma and the nucleus, the solid inner core of a comet. The brightest part part of a comet, the comet's head, is made up of the nucleus and the coma. Just a reminder, you could be adding things to your graphic organizer while we're reading, or you can wait until after we're done reading, so just keep that in mind. Comet's tail. As a comet approaches the sun and heats up, some of its gas and dust stream outward, forming a tail. The name comet means long-haired star in Greek. Most comets have two tails, a gas tail and a dust tail. Both tails usually point away from the sun, as shown in figure 25. A comet's tail can be more than 100 kilometers long, holy mackerel, and stretch across most of the sky. The material is stretched out very thinly, however, so there is little mass in a comet's tail. Origin of comets. Most comets are found in one of two distant regions of the solar system, the Kuiper belt and the Oort cloud. That's another one of my favorite words in science. The Kuiper belt is a donut-shaped region that extends from beyond Neptune's orbit to about 100 times the Earth's distance from the sun. The Oort cloud is a spherical region of comets that surrounds the solar system out to more than 1,000 times the distance between Pluto and the sun. All right, so I'm going to give you a solid minute to 2 minutes and have some things written down on your chart for comets. You need to have some things written down in your chart for comets. Yes, Joe?
What if I don't get all of them?
That's okay if you don't get everything.
Because it didn't talk about the location or size and shape.
Are you sure it
Well-
didn't talk about the size and shape and location?
Or wait, the size, the shape and the location, but not the size.
This column.
You know what? They didn't give an actual number size, but they did compare it to something. Back in that very first paragraph. See if you can find it, Joe. Yes, Jordan?
So, is the size to all of them only circle/oval?
That's the size of their orbit. Do you understand what an orbit is?
Oops.
An orbit is the path that it makes around something else. So that could maybe be another characteristic you could add to your chart if you wanted to. Yes, Dean?
I have two questions.
Sure.
It compares it to a dirty snowball. Could that be for color and for shape?
I would accept both of those. Yeah, those are good ideas. Nicole W.
Did it say travel speed?
It did not say travel speed. So even though we came up with that, we might not always get an answer, and that's okay. Ayush, did you have something else you wanted to add?
Same thing.
Okay. All right. Are there any new characteristics that you guys added in? That's my first question. Did anybody come up with any new characteristics that they wanted to add onto their chart after we read that first chunk? Yomna, what did you add in? Okay, you had shape as mountain. Good. I'm looking specifically for anything you added in this column, though, the characteristics column. You added color. Great idea. Angela, what else did you add?
I added what it was made from.
Okay, composition, what it's made of. Good. Anything else? Nicole W?
What they look like?
What they look like, their appearance. Good. Excellent. All right. Yes, Joe, last one.
Oh, it's origin.
Origin or location. Yes, that works. All right, so real quick, let's get 3 examples of characteristics you found specifically about comets. It could be anything you wrote down. Who can tell me one characteristic of a comet? Alyssa.
For shape, I put down dirty snowball.
Okay, kind of shaped like a snowball. That's one characteristic. Montreal, characteristic 2.
Wait, can it be comet tail?
It could be about the comet's tail.
For size, I put 100 kilometers.
Okay, so the size of its tail, 100 kilometers. Excellent. That's okay. You can pronounce it that way also. Joe, one more.
Oh, I had for shape a dirty snowball.
Excellent. That's what Miss Alyssa mentioned. That's okay.
Oh.
You got another one you want to share instead?
Oh.
What about your origin question? Did you answer that one?
Oh yeah. The
It's those 2 fun words.
the Jupiter belt and the Oort cloud.
Perfect. Good job. Yes, Montreal.
For made of, I put.
All right, so the composition, ice, good. All right, then, go ahead and flip to page 732, I believe it is. Asteroids comes next, yeah? Yes, Ange.
This column.
I think so. Yeah, Troy, what's up?
So, aren't comets or asteroid or meteors made out of like stars or something?
Not necessarily. are much, much, much farther away than most meteors and asteroids.
I heard like something similar. What makes the comets?
Oh, what makes the comets? Yeah. And you know what, when we actually get into our astronomy unit, we'll talk a little bit more about that, okay?
Oh yeah, comets are stars.
Hang on, we're going to talk about it. All right, up next is asteroids. So that is your middle column. So once again, as we're reading, you could be adding categories or characteristics onto the left side, and you could also then be adding in the specific characteristics of an asteroid. So this time around, would somebody like to read the first paragraph, please? Ange, go ahead.
Asteroids. Between 1801 and 1807, astronomers discovered 4 small objects between the orbits of Mars and Jupiter. They named the objects Ceres, Pallas, Juno, and Vesta.
Good job.
Over the next 80 years, astronomers found 300 more. The rocky objects called asteroids are too small, too numerous to be considered full-fledged planets. Most asteroids revolve around the sun between the orbits of Mars and Jupiter. This region of the solar system is shown in Figure 25. It is called the asteroid belt.
Excellent. All right, paragraph 2. Joseph, go ahead, buddy.
Astronomers have discovered more than 100,000 asteroids, and they are consistently finding more. More asteroids are small than a kilometer in diameter.
Good, thank you.
Only-
Can you pause for just a second, Joey? Do we know what a diameter is? We might have talked about it in math class. Probably not this year, but maybe last year in 5th grade. Ayush?
Diameter is the height of a circle.
Circles, because they're two-dimensional, don't technically have a height, but I know what you're trying to say. Do you mean like the distance across of them? Yeah, good. So the distance across a circle is the diameter. So the distance across an asteroid, Ceres, Pallas, and Vesta, were like 300 kilometers. All right, go ahead, Joey. Thank you for being patient.
Only Ceres,
Good.
Pallas, and Vesta are more than 300 kilometers across. At one time, scientists thought that asteroids were the remains of a shattered planet. However, the combined mass of all the asteroids is too small to support this idea. Scientists now hypothesize that the asteroids are leftover pieces of the early solar system that never came together to form a planet.
Excellent. Thank you. Gracie, you want to read the next paragraph? Go for it, bud.
Some asteroids have very elliptical orbits that bring them closer to the sun than Earth's orbit. Someday, one of these asteroids could hit Earth. One or more large asteroids did hit Earth about 65 million years ago, filling the atmosphere with dust and smoke and blocking out sunlight around the world. Scientists hypothesize that many species of organisms, including the dinosaurs, became extinct as a result.
Excellent. Thank you. All right, so let's take a full minute to 2 minutes and fill in our column for asteroids. Fill in any information you were reading about asteroids for any characteristics. And if you thought of some new characteristics, you can add more characteristics onto your table too. Both are options. Yes, Troy. You don't know what to write about what? The asteroids? Did you hear anything about the size of the asteroids? No. Are you sure? Do you remember that word I explained with Ayush? What was that word? Diameter. Do you think that might be the size of it? Diameter is the distance across a circle. So they're saying like the distance across the asteroid is 300 kilometers. Does that sound like a size to you? Thank you for raising your hand. I'll be right with you. You got it? You're good, Troy? Yes. Whenever you're done writing, you can go grab the boys' pass and get a drink. Montreal, how may I help you?
Would that be size or would that be travel speed?
That would be size. Speed would be a distance and a time with it, like kilometers per hour or meters per second. Did it?
Yeah, right here.
Where did you see that? No, it said- Well, if you find it, write it down and show me. Oh, it's on the other side. Okay. That's meteors. Well, we'll get to that in a couple minutes. Yes, Joe?
I didn't find anything about the travel speed, the origin, or the size.
Origin I think is in
found one
there.
for the
See if you can
size.
find, and size also. Size was what we discussed with the diameter.
Oh, so
And origin means where you can find them. Where are they located? Yes, Montreal.
I don't know what the label on the characteristic of this.
What to label what? I'm sorry.
It says,
Oh, a new characteristic. Okay.
it says 65.
Well, that's a specific incident, maybe not a characteristic. You could say something like, I'm trying to think of how we could abbreviate it. Something like likelihood of hitting Earth or something like that. We could do that as a characteristic, yeah. Because some of them can come to Earth, some of them don't. What, likelihood? Likelihood is all one word. Yes, Ange?
If they were to hit it, wouldn't they have to like break the pattern?
They would have to break out of that belt, yes. Alrighty, so let's start with first. Did anybody come up with any new characteristics? Any new characteristics? You know, what did you think of? Never mind, that's okay. Montreal, you came up with a good one. What did you come up with? We were just talking about it.
I know it, like
Did you-
likelihood of hitting Earth.
Likelihood of hitting the Earth. Excellent, that's a good one. I liked that. That was thinking outside the box. Angela?
The most are small, usually 1 kilometer in diameter.
Okay, that's a specific characteristic for just asteroids. I was asking about any new characteristic categories. That's okay. So, no, you might not have. That's up to you. Remember what I said. You're using the graphic organizer to help you. If you didn't see anything new that you thought was relevant, don't add it in. That's okay. All right, Angela.
Found in an asteroid belt.
Okay, asteroid belt. That would probably be location. But yes, that is true. All right, any other specifics then about asteroids? So things that you put in the asteroid column. Nina.
Their size is less than a kilometer in diameter.
Size is less than a kilometer in diameter. Joseph.
I have a question.
Sure, what's up?
What Angela said about like the asteroid belt, would that go and fit into origin?
I'm sorry, can you repeat it?
Oh.
Repeat your question.
Would
The asteroid belt?
Yeah, the asteroid belt fit into origin?
Yes, that is where they originate. That is their location. Mr. Taco.
They are shaped like rocky objects.
They're a rocky-shaped object. Good. And Montreal, the last one.
About 100,000 asteroids.
Okay, so maybe amount. That's a new category and a new fact. That's a good one. I like that. All right, so here's the deal. I need you to freeze and stay still while I give directions. There are only about 1.5 minutes, 2 minutes left. So let me summarize real quick before you pack up. Freeze, freeze. Give me 30 seconds. Thank you. All right, what we're going to continue to do is then also fill in for meteors. And then the thing that you can do that's really nice is you can then look at your chart and find things across the rows that they have in common. So you could say, oh, comets are this big and meteors are that big. That's something they have in common. That's a similarity. Shape. Comets are more circular like a snowball. Asteroids are kind of rocky and mountainous looking. That's a difference. So the chart allows you to find those similarities and differences and make those conclusions while you're reading. So it helps you to better be prepared as you're reading your textbook. All right? Any questions before I let you get all packed up and ready to go? Montreal. We're going to continue it again next week in Intervention one day, okay? I'm not going to be here tomorrow. All right, then, I will hold on to your papers for you. I need you to do me a big favor and put the textbooks back in the cabinet for me, and we can get packed up and ready to go.